Hello and welcome to another IB Mathematical Studies video. This one is about linear equations. And before we do that, we're going to quickly just revise the power rules. Because linear equations happen when we just have a simple x. And it can be confusing at times because if you have 1 over x, you might think, well, I have a simple x, it's just at the bottom. Well, that's not the case because remember 1 over x is equal to x to the power of minus 1. So remember to revise your power rules before you start dealing with linear equations and make sure that you know how to deal with them properly. This is the only case of x in which we have a linear equation. Okay? Again, we can look at these and we can see that this is a linear equation because x is to the power of 1. This is also a linear equation, x to the power of 1. This one's not, x is to the power of 2, so no linear equation here. And this is the one I was talking about, x to the power of minus 1, no linear equation. So we have all these different ways of writing the equations, and when we move things around and we simplify them, we end up having what we call the general form. And the general form, the only thing it means is that we've moved things around to put the equation in the simplest manner. And these are the two kind of simplest manners in which you will find equations. Particularly interesting, I'm going to highlight it, is this one here. This one is the important one, really. And we're going to see why. So, for example, here we have two equations, and we're going to check if they're written in the general form. Well, in this case here, y is here by itself on the side. So, we could put it in this form here. Or we could just keep it like this, because this is also a general form, okay? And these two here need to be moved around, and that's what we do. And the important thing about linear equations is that, and that's why they're called linear, is because when we represent them in a graph, they graph into a line. So these are all straight lines. You can see them here. And if you look at them, you're going to realize that what changes is the slope. You might have ones that are like this, ones that are like this, ones that are like this. Straight, but with different slopes. And that's going to be a very important thing to figure out. And also, the important thing with the linear equation is that every straight line that you can draw on a graph is a linear equation. Okay? So, how do we use the graph? Well, what we actually do with the graph is the graph tells us important things. It tells us the slope, which is going to be an important feature that we're going to keep looking. We're going to keep investigating more and more as the year goes by. But it also tells us the actual solutions to the equation, because if you think about it, if you have this case here, and imagine that y equals 0, well, 0 equals x plus 1. Well, x is going to equal minus 1, so that will be a solution, and that will be this point here. So we can find the solutions for x equals 0 and y equals 0 with the places in which the line cuts the axis. And that's another very important thing about graphing, which is that it's going to tell solutions for y and x equaling 0. When we have two linear equations, this is another very interesting feature of lines. The point where they cross is going to be a common point. It's going to be a point where they're both true for those numbers. So if you put, in this example, minus 2 and minus 1 inside these two equations here, you'll see that they both become true. When I mean that the equation becomes true, I'm saying that, for example, when we put it in here, we would get minus 1 equals minus 2 plus 1, which is true because minus 1 would then equal minus 1. So that would be fine. This plus here is very funny, I'm sorry. That would be true because minus 1 is equal minus 1. But if we put different things here, we might end up with, for example, 1 equals 0, which is not true. So that's what I mean when I'm saying that an equation is true. And these two lines cross at just one point, and that means that the set of two linear equations has just one solution. And that's what we're looking for. So graphs can also help us solve systems of equations or simultaneous equations. Can we solve systems without a graph? The answer is yes. And this is an example here. The best way to do it, and the one we're going to be working about, is substitution. and it's very interesting because it's actually very powerful and it always works. So there are other ways of solving the simultaneous equations, and you've probably seen them, but we're just going to focus on substitution for the IB mathematical status because it's always going to work. So here's a little invitation so that we get better in understanding the linear equations and how this works and what does changing m do and what does changing c do. I invite you to try in your graphing calculator, in your GDC, to try to represent the picture here. See if you can get it to happen. It's actually not that hard. Just start drawing lines and you'll figure out what happens when m is negative, when m is positive, when m is big, when m is small, when c is big, when c is small. And it's quite an interesting game because you can make the different drawings. Some of them can be cooler than mine, I'm sure. Mine is not that great. And you can challenge other people to see if they're able to reproduce those lines. It's a tricky one, and it certainly helps you to understand what really goes on when m changes and what really goes on when c changes. And that is going to be a very important thing to understand in things to come. So that's it. Thank you very much for watching, and see you later again. Bye bye.